we have another question. Question number 2 says, a gas sample initially at 23 degrees Celsius is cooled to minus 173 degrees Celsius. Calculate the ratio of the initial volume to the final volume at constant pressure. Now, remember, the first step is to list the given parameters. So our solution, we are given T1 equals to 23 degrees Celsius. As we are listing, we are converting T1 immediately. So T1, which is in Celsius, we solve with Kelvin. And for you to solve with Kelvin, you add 273, which will give us 300 Kelvin. You don't solve your gas law questions using degrees Celsius. You solve it in Kelvin. And for you to convert degrees temperature to Kelvin, you add 273. So once you add 273 to degrees Celsius, you have your temperature in Kelvin. All right, that's for T1. And it's cooled to this temperature. So this was the initial. Once you hear initial talks about T1 or V1 or P1, whether it is initial is talking about the first one. Okay, so here we have looked at initial. So the next temperature you are seeing is T2. So T2 equals to minus 173 degrees Celsius. Remember, we'll convert to Kelvin. So when you add 273, you will have 100 Kelvin. Of course, minus, you literally remove 173 from here to get 100. Alright, so they ask us to calculate the ratio of the initial volume to the final volume. So the next parameter here is V1 to V2. So we're asked to calculate this. We're asked to calculate the ratio of V1 to V2. So looking at the parameters that are mentioned, and it says at constant pressure. So we are not considering pressure. What particular gas law considers just the volume and the temperature? And that law is the Charles law. And Charles law states that the volume of a given mass of a gas is directly proportional to its temperature at constant pressure. So we have that. Volume is directly proportional to temperature at constant pressure. When you bring in the constant of proportionality, you have this. And making K subject of the formula, K is equals to V over T. So V1 over T1 is equals to V2 over T2. Now, looking at this, our question asked us, remember I always say, once you write down the formula, then the next step is to rearrange it to suit the question that you are asked. Now, we are asked for the ratio of V1 to V2. That is different from when you are given maybe V1 and asked to find V2. Or when you are given maybe V2 and asked to find V1. That is different. In this case, you are asked to find a ratio. And if you understand the gas law very well, you will know that temperature and volume are in direct proportion. So if temperature increases, the volume increases. If temperature decreases, the volume decreases. Which means that V1 is to V2 will be equals to T1 is to T2. Because it is a direct proportion. Look at this. Look at this. It's a direct proportion. That is why we have that V1 is to V2 is equals to T1 is to T2. Or if you are confused about this, you can still use this and go a long route and still end up with this. But remember, the law is a direct proportion. So if this is increasing, this will also increase. So you can have it this way. So V1 is to V2, we will equals to T1 is to T2. So now we are given just T1 and T2. Let's fill in our parameters. Okay, so our V1 is to V2 is equals to, what is our T1? T1 is 300 is to, what is our T2? 100. So we reduce this to the lowest term. Of course, 100 here will give you 3, 100 here is 1. So V1 is to V2 will be 3 is to 1. So the ratio of the initial volume to the final volume is 3 is to 1. That is our answer. All right.